Hi, this is Brian Hagelstra. We're going to take a look at how to make a scatter plot with Excel and work with linear regression and quantitative literacy. As your first step, you want to make sure you get your table into your Excel spreadsheet. To make a scatter plot, go ahead and highlight that table and go to Insert, Graph, and here's some of our scatter plots right here. I can also go ahead and move the chart to its own sheet, so I have a little larger graph to work with. One of the things I would like to ask you to do is to get some labels on your axes so that it'd be more clear for people in terms of what you're working on. So if I go to the plus sign here, chart elements, I can go ahead and put an axis title and start getting those on. So going over here, deleting what's there, and putting in here degrees, or actually in this case here, cricket chirps. Per minute. And then down below, we have degrees Fahrenheit. Now when we print this off for other people to look at or share with other people in a digital way, it'd be more clear in terms of what the data was that we were working on. If I go to any of the data points here and point at it, I can do what's called a right click. You usually use the left part of your mouse, but this case here is the right click, and then go add trendline. And I can make some choices here. The default is linear. We're going to do linear today. But one of the things that might be kind of nice to do is to display the equation and display the r-squared value. And now that's going to occur on your graph. And now we can go ahead and use the equation and the r-squared value. If you want to, you can go ahead and increase the size of it, make it a little easier to work with. We can now look at the graph to try to eye the graph to make predictions. Or, since we have the equation now to go with this, we can actually use the equation to make some predictions as well. I've gone ahead and done some scratch work already for making some predictions. The first prediction I want to take a look at is what happens when it's 85 degrees Fahrenheit. And we could kind of eye it. The 85 here kind of go up and then kind of go on over. Somewhere here maybe about 190 perhaps. Just kind of eyeing it. Of course, that's the problem about eyeing the graph. That's where the equation come in real handy. Since I went ahead and worked with this already, I actually found out the answer is 193.5. So one of the things I can do is go to Insert and go with Shapes and create a text box, or just go with the square here, either one here. So creating a text box. Problem with the text box is that, well, you may have some stuff in the background. That's why sometimes I actually like going with the square. Now kind of blank that out a little bit. So my first prediction here, just kind of working with this, is with the 85 degrees Fahrenheit. So using the equation, I found that at 85 degrees Fahrenheit, I found that I can make a prediction of around 193 to 194 cricket chirps per minute. Notice that with my prediction, I'm writing a complete sentence. Also, I'm making sure that I'm including my units here to go with my prediction so people are clear on what's going on with my prediction. Also, if we've been talking about interpolation and extrapolation, might be nice to be able to go ahead and note that with our prediction as well. Since we are making a prediction, between two known values, we have an interpolation, which is a safer prediction. So just kind of doing an example of an interpolation. If we want to, we can get the arrow going and even kind of point out where our prediction is in the graph here for people to be able to eye it as well. Okay, I'm going to use my back arrows here and eliminate this. And let's do a different prediction. Okay, an example of an extrapolation. Problem with extrapolation, with the line that's been drawn in with our trend line here, it might go beyond the data this way or that way. Now, let's make a prediction for 100 degrees Fahrenheit. So I'm actually coming over here to the edge. One of the things I can do is point at that trend line, do a right click, and I can format the trend line. And one of the things I may want to do is go forward. Since I want to make a prediction for 100 degrees Fahrenheit, 90 is the last value, I want to go forward by at least 10, but I often will go overshoot it a little bit, and let's go 20, and let's see what happens. And so now Excel has extended this line out 20 units with regards to the X values here, and now I can maybe have that 100 value right on the screen with the line here that's going with our equation here. Once again, using the equation and did some scratch work already, I found out that with 100 degrees, we would have 258 cricket chirps per minute. So once again, I can go with the insert, take a look for shapes, get my square going. For 100 degrees Fahrenheit, I can use the equation and graph to make a prediction of 258 cricket chirps per minute. This is an example of extrapolation, which has some risk involved. So I am using the equation to make a prediction. It does seem somewhat reasonable if we have this here at 90 degrees, just going up to 100 degrees here, that maybe we would have 258 cricket chirps per minute. But there is always a chance of what's called model breakdown. Model breakdown is when the equation and the graph no longer accurately predict what's going on. Let's try to make another prediction here where I'm going to extend this even further. So I'm going to do a right click, format plot area, actually format trend line. So let's make sure I'm on there, format trend line. And let's move this forward 400. So we're extending way beyond the known data. And using my equation here for 450 degrees, the equation comes up with 1,763 cricket chirps per minute. I'm going to write that down, but then we're going to talk about it. So making my prediction here, using the equation and graph, I predict that there will be 1,763 cricket chirps per minute at 450 degrees Fahrenheit. However, I believe this is a model breakdown because toasted crickets do not chirp. So even though I've extended that line out and I've used the equation to get that number 1,763, the prediction is not reasonable. At 450 degrees Fahrenheit, the crickets will not chirp at all. So this would be a model breakdown. So just because the equation on the graph says it's true doesn't necessarily mean that it is true. Sometimes we've got to think about what's going on and what some of our underlying assumptions are. For these predictions to work, one of our underlying assumptions would be that, well, the crickets are alive. So if we go too cold, the crickets will be frozen, they won't chirp. And if we go the other extreme, too hot, the crickets will be toasted and they won't chirp for that reason as well. At some point, what's going to be happening to our data that we're not seeing with our line is that it will have to level off and maybe start dropping as the crickets start dying. This is Brian Hagelstrom working with Excel and making scatter plots and working with linear regression and then using quantitative literacy to try to make some predictions.